Creating app container. In part 1, we finished setting up Docker, downloaded the exercise files, and added them to Visual Studio Code Workspace. In this part, we will create a Docker container for our simple to-do application, which runs on Node.js. No prior knowledge of Node.js is required to follow along. All you need is Docker running in the background, an IDE or text editor of your choice, and the exercise files that we have already downloaded. Creating image. The first step in containerizing the application is to create an image, which will then be used to run the application in a container. To build the image, we will use a Dockerfile. A Dockerfile is a text-based file, without a file extension, that contains instructions for Docker to create a container image. Let's take a look at the Dockerfile located in the root folder of the application. From node:12-alpine, this line specifies the base image to use for the Docker image being built. From keyword is used to start the definition of a new image, and the argument node:12-alpine is the name and tag of the base image. In this case, the base image is the official Node.js image, version 12, built on Alpine Linux. Alpine Linux is a lightweight and secure distribution of Linux, making it a popular choice for building Docker images. The Alpine tag indicates that this particular version of the Node.js image is built on Alpine Linux. The base image provides a starting point for the Docker image being built, and any additional instructions in the Dockerfile will be applied on top of this base image. The base image should include all the dependencies and configurations required to run the application in a container. By using the official Node.js image, we can be sure that the necessary dependencies for running a Node.js application are already included in the image. Run apk add, no cache, Python 2, G++, make. This line specifies a command to run during the image building process. The run keyword is used to execute shell commands in the image. In this case, the command apk add, no cache, Python 2, G++, make is used to install the Python 2, GNU compiler collection, GCC, and make packages in the image. The apk command is used to manage packages on Alpine Linux, which is the operating system used in the base image. The add option is used to install new packages, and the no cache option is used to prevent the package cache from being stored in the image, reducing its size. This command installs the required dependencies for building and running the application. The Python 2 package is likely required for some build tool or dependency. The GCC package is a common compiler tool chain required for building many types of software, and the make package is a build automation tool used to compile and link source code into executables. By including these dependencies in the Docker image, we ensure that the application has everything it needs to run, regardless of the environment in which it is run. This makes it easier to develop, test, and deploy the application, as we do not need to worry about installing these dependencies on each host machine. Work dir/app. This line sets the working directory for subsequent instructions in the Dockerfile. In this case, the working directory is set to app, which is the default location in the image where the application files will be stored. Copy. This line copies the files in the current directory to the working directory in the image. The first dot specifies the source of the files to copy, and the second dot specifies the destination in the image. Run npm install. This line runs the npm install command, which is used to install the required dependencies for the application. The dependencies are specified in the package.json file, which should be present in the current directory. cmd npm start. This line specifies the default command to run when a container is started from the image. In this case, the npm start command is specified, which is used to start the application. Expose 3000. The final line exposes port 3000, which is used by the application. This allows incoming traffic on port 3000 to reach the application running in the container. To build a container using this Dockerfile, we will run the following command from the root folder of our exercise files. Docker build -t, my app, done. Let's break this down. First, we have the Docker build command. This is the command we use to build a Docker image for our application. When we run this command, Docker takes the instructions in our Dockerfile and creates an image, which is like a snapshot of our application. Next, we have the -t, my app flag. This flag gives a name to our image. In this case, we're naming it my app. Finally, we have the dot at the end of the command. This is the location of our project files, including the Docker file. Think of it like the address of our project. The dot at the end tells Docker to look in the current directory for the project files. To run this command, open a new terminal window using the terminal and then new terminal option. In the terminal window, type the command and press enter. Docker will now start building the image using the instructions provided in the Docker file. You might have noticed that Docker downloaded a lot of layers. This is because you instructed the builder that you wanted to start from the node:12-alpine image. But, since you didn't have that on your machine, Docker needed to download the image. Image is now created and you can check that in Docker Desktop app. Starting app container. We can now run our application in a container. To do so, we will use the following command. Docker run -dp 3000:3000 my app. Docker run tells Docker to create and start a new container. -dp are two options that are passed to the Docker run command. The -d option tells Docker to run the container in the background, while the -p option specifies the port mapping that we want to use. 3000:3000 is the port mapping that we want to use. In this case, we're telling Docker to map port 3000 on the host machine to port 3000 inside the container. And finally, my app is the name of the Docker image that we want to use to create the container. So, this command creates and starts a new Docker container based on the my app image, with port 3000 inside the container mapped to port 3000 on the host machine. The -d option ensures that the container runs in the background, so we can continue to use the terminal for other tasks. This command is particularly useful for running applications that have been containerized using Docker. By mapping the ports in this way, we can access the application running inside the container from our web browser or other tools on the host machine. Now, execute the command from a terminal window and wait for a few seconds, while Docker creates the container and starts it. You can open Docker Desktop to see the container that we have just created. You might notice that Docker has assigned a random name to the container. This is because we didn't specify a container name in the command. You can do so by using name tag like this. Now, open a web browser and go to http://localhost port 3000 to see the app in action. Go ahead and add an item or two and see that it works as you expect. You can mark items as complete and remove items. Your front end is successfully storing items in the back end. At this point, you should have a running to-do list manager with a few items, all built by you. Chapter Summary. In this video we have learned how to build a Docker image using Docker build command and how to create and run a container using the Docker run command. We ran both commands from the root folder of our application using a terminal window. Finally, we launched the application using a browser and explored different functions that application offered. In the next video we will learn how to update our application, so stay tuned.